Let's continue with the integration of rational functions by partial fractions. The next case we want to think about is when the denominator's degree is higher than numerator's degree, and denominator can be factored into different linear factors. So what I'm saying is this is the numerator. Numerator's degree is lower than the denominator's degree. And the denominator can be factored into the k different linear factors. So as I said, if you have webcam, could you please activate your webcam? Let's do an example. Evaluate integration 7x squared plus 2x minus 7 over x cubed minus x dx. In this case, we have to work on partial fractions. The first thing we observe will be the degree of the numerator and denominator. We notice that the degree of the numerator is 2 and the degree of the denominator is 3. So in that case, we don't go through long division. Instead, we will factor the denominator. The common factor in the denominator is x. So we will take out x, and then it becomes x times x squared minus 1. And then the formula we know is a squared minus b squared can be factored into a minus b times a plus b. So we understand x squared minus 1 as x squared minus 1 squared. And so it fit into this situation. And so the denominator will become x times x minus 1 times x plus 1. And then we do a over x plus b over x minus 1 plus c over x plus 1. So we just split that into 3 fractions, and then we will put these two are equal, and we will try to figure out what a and b and c must be. So we splitted that into 3 fractions, and then the way we will work out the problem would be we will think about the common denominator, which will be like this again. So this one is the first one will be a over x times. To have the common denominator, we have to multiply x minus 1, x plus 1. But we have to do that to the numerator and denominator. The second one is b over x minus 1. But to make the common denominator, we have to multiply by x times x plus 1. We do it to the numerator and on the denominator. The third fraction is c over x plus 1. So we have to multiply by x times x minus 1 on the numerator and denominator. After that, we will combine all those things which have a common denominator. So x times x minus 1 times x plus 1. And then let's write everything down together. But let's just expand this out. And then this one is x minus 1 times x plus 1. And by the formula, it becomes x squared minus 1 squared, which is 1, plus b times the distribution. Then that is x squared plus x plus c times this one times this one will be x squared minus x. So denominator is x times x minus 1 times x plus 1. And then we will think about the degree 2 terms together. And then that'll be this one, and this one. So that'll be a plus b plus c times x squared. And then the next one is x times something. So it'll be b and minus c. Plus b minus c x and minus a. Any question about this? So what's going on here is we started here and we split it that into 3 fractions, and then we combine them together. And we got this one, right? So what we notice here is a coefficient of x squared is 7, but it became a plus b plus c. And the coefficient of x is 2, but it became b minus c. And then the constant term was minus 7. And it appeared as a, right? So from there, minus a equals minus 7. And a plus b plus c equals 7, right? Here and here, the coefficient of x squared. And then 2, the coefficient of x is the same as b minus c, that equals 2. So from here, a equals 7 by multiplying by 7 on both sides. And then we will apply this result to the second one and third one. Then we get 7 plus b plus c equals 7. So what does that mean? We just subtract 7 on both sides. Then we have b plus c equals 0. Right? And in the third one, we have b minus c equals 2. Correct? Any questions so far? So we have 2 equations. So we add them up vertically. Then c will cancel each other. And we have 2b equals 2. So b equals 1. So we have a equals 7, b equals 1, and then we apply b equals 1 to here. And then b equals 1 plus c equals 0. So c equals minus 1. So we got a, b, and c. Any question? What we will do will be we will put this result here to get 3 separate fractions. And then when we think about the integration, we can just apply natural log for each term, right? So what you can say is, let's go back to the original question. Original question is 7x squared plus 2x minus 7 over x cubed minus x dx. So that equals integration 7 over x plus 1 over x minus 1 minus 1 over x plus 1 dx. Okay. So that is what? We just do term by term integration. Then that is 7 times natural log of absolute value of x plus natural log of absolute value of x minus 1 minus natural log of absolute value of x plus 1 plus c. So we want to combine all of those. How can we do that? Let's do just one by one. If there is a number in front of a logarithmic function, then that can be raised to the power. So we can write it as x to the 7th power plus natural log of absolute value of x minus 1 minus natural log of x plus 1 plus c. And then what should we do? We can combine these two. If a logarithmic function with the same base number are added, then inputs can be multiplied. So natural log of absolute value of x squared times x minus 1 minus natural log of absolute value of x plus 1 plus c. So this is minus, and so this one is natural log of absolute value of x squared times x minus 1 over x plus 1. So minus means division plus c. So that is the conclusion for this problem. Let me summarize the logarithmic rule which I used. N times natural log of x can be written as natural log of x to the n power. And natural log of a minus natural log of b, and that is natural log of a over b. And natural log of a plus natural log of b equals natural log of a times b. Oh, I'm sorry. It is not 7th. It is not squared. It is 7th power. Sorry, I just changed it. Any question about this? As I said, in this case, what happened was the denominator's degree is larger than numerator's degree. So we don't go through the long division. And another characteristic of this fraction is that the denominator factored into k different linear factors. Then what we did was we separate the fractions like this, and then we figure out what are A1, A2, and AK. And then we do term by term integration. Basically, what we are thinking about is thinking about the natural log after the integration. Integration of 1 over x equals natural log of absolute value of x. Different from this previous case, case 3, the denominator cannot be factored into k different linear factors, but denominator's degree is bigger than the numerator's degree. So we don't go through the long division. So the originally that is P of X over Q of X, and then the numerator is P of X and denominator is AX plus B to the N power. So it is just a AX plus B to the N power, and just it has one factor. I mean, one factor to the N power. In that case, what we do is we will split the denominator, the fraction, into N fractions with various degree. So A1 over AX plus B plus A2 over AX plus B squared plus, and so the denominator degree will keep on going and going like that until it becomes the highest degree. So AN over AX plus B to the N power. All right. The next example will be the combination of the linear factor and the nth power. Evaluate integration 3x squared minus 23x plus 44 over 2x plus 1 times x minus 2 squared dx. For this fraction, what we want to do is just to combine the previous technique with the new technique. So there is one linear factor and the other factor is raised to the power. So we will split that into 3 pieces. 3x squared minus 23x plus 44 over 2x plus 1 times x minus 2 squared is a over 2x plus 1 plus b over x minus 2 plus c over x minus 2 squared. That means we will split the different factor, but if one of the factor is raised to the power, then we apply this rule. And so we start with the lowest degree to the highest degree. And then the remaining step will be the same. We will think about the common denominator. And then after we combine all those together, we will compare the coefficient of x squared, xn constant term with the fraction we started from. So a over 2x plus 1 And the common denominator is 2x plus 1 times x minus 2 squared, and we wrote 2x plus 1. So what is left is x minus 2 squared. We do it on the numerator and on the denominator. And the next one is b over x minus 2. What is left is a 2x plus 1, but it is 1 less degree, so we have to multiply by x minus 2. We do it to the numerator and the denominator. Plus c over x minus 2 squared times 2x plus 1 over 2x plus 1 by considering the common denominator again. Before we put all things together, let's work on x minus 2 squared and 2x plus 1 times x minus 2. So x minus 2 squared equals, you can use the formula, or you can just do FOIL if you cannot remember the formula. So FOIL. So x squared minus 2x minus 2x plus 4. So that is x squared minus 4x plus 4. The next thing is 2x plus 1 times x minus 2. So we will do FOIL again. So 2x plus 1 times x minus 2. So that equals this one times this one. 2x times x is 2x squared. 2 times 2 is 4, so minus 4x. 1 times x is x. 1 times minus 2 is minus 2. So that is 2x squared minus 3x minus 2. So question in the chat box, the I think right above or right below the Zoom link on the course website, there is a tab which indicate Zoom recording. Then if you click there, then you can see the recording in the past. So if you cannot attend, then you can refer to that page. Let's apply that to this fraction. So this is in the parenthesis. Then this will continue as the long fraction with common denominator 2x plus 1 times x minus 2 squared. So a times we already expanded that was x squared minus 4x plus 4 plus b times the next one was 2x squared minus 3x minus 2 plus let's just write it down, c times 2x plus 1. Let's expand that out. So I think it is better to expand that out and combine with the same degree term. Otherwise, you will be confused. So a x squared minus 4a x plus 4a plus 2b x squared minus 3b x minus 2b plus 2c x plus c. So I just did distribution. And then we combine the same degree term. So this are the same degree. So that is a plus 2b x squared plus, let's sort out x related term. Then that will become minus 4a minus 3b plus 2c x plus the remaining one, 4a minus 2b plus c. Okay, and so we have the equations a plus 2b equals what? So that is the coefficient of x squared. So that becomes 3. And the next one is minus 4a minus 3b plus 2c equals coefficient of x, which is minus 23. And then constant term is 4a minus 2b plus c equals 44. So we have to solve this equation. Let's consider minus 2c. Then that is minus 8a plus 4b minus 2c equals minus 88. So our strategy is if you see A, then it consists of large A and large B. And so from B and C, we want to eliminate C. So that's the reason we thought about minus 2C. And then what we want to do is we want to combine that with B. So minus 4A plus 3B plus 2C equals minus 23. So we add vertically, then we get minus 12A plus B equals minus 111. Let's say this is D. So we combined B and C and we got the equation which consists of A and B. So now we can combine A and D. So what we want to do is that we want to think about A and minus 2B to make B equal. So A is A plus 2B equals 3. And if we multiply minus 2 here, then we get 24A minus 2B equals 222, right? So when we add vertically, these B related thing will cancel each other, and 25A equals 225. So A equals, you just divide by 25 on both sides, then it becomes 9. Because 250 is 10 times 25, and so 225 is 9, right? 9 times 25. So we will apply this to A. So that means here is A is 9 plus 2B equals 3. So two B equals minus 6. We just subtract 9 on both sides. And then we divide by 2 on both sides. So B equals minus 3. And then we got A and B. So we apply this to C. And then that is 4 times 9 minus 2 times minus 3 plus C equals 44. So that is 36 plus 6 plus C equals 44. And then this one is 42 plus C equals 44. So C equals 2. We subtract 42 on both sides. So we got A, B, and C. So let's go back to the original integration. The integration which is given to us is an integration of 3x squared minus 23x plus 44 over 2x plus 1 times x minus 2 squared dx. Based on our result, what we can write is that can be written as 9 over 2x plus 1 minus 3 over x minus 2 plus 2 over x minus 2 squared dx. So that is 9 times integration 1 over 2x plus 1 dx minus 3 times integration 1 over x minus 2 dx plus 2 times integration 1 over x minus 2 squared dx. what you can notice from here is what you can notice here is the first two can be used natural log, but third one is not. So for third one, we will use the substitution method to solve the problem. What we will think about is u equals x minus 2, and then du equals dx. So this can be perceived as integration u to the minus 2 dx du. So that can be written as minus 2 plus 1 over minus 2 plus 1 plus c. So that is -1 power. This one is u to the minus 1 power, which is 1 over u. And this one is minus 1. So minus 1 over u plus c. So we can say that that is minus 1 over x minus 2 plus c. So we got this part, and the other part is just a natural log. If there is a number in front of x, then we will have to divide. Any questions so far? All right, so let's combine everything to get the conclusion. So for the first term, 9, but 2 is in front of x, so we have to divide by 9 over 2, and then natural log of absolute value of 2x plus 1 and minus 3. And then this integration is natural log of absolute value of x minus 2. And then there was 2, and we multiply by this fraction. So it becomes minus 2 over x minus 2 plus c. Any question? Okay, and then if you don't have any question, then you can leave. Otherwise, you can remain and continue to ask me question.